Hello, we are Team BananaBots from Slovakia, and we are currently studying at the Secondary School of Electrical Engineering in Prešov.
Hello, my name is Tomáš, and I was making the hardware of the robot and also taking part in programming of the robot.
I'm Lukáš, I was Lego builder and programmer, and I was helping with hardware.
My name is Pavel, and I was programmer, and I was designing all 3D printed parts.
Hi, I'm Veronika, and I was poster and performance designer.
Hi, I am Tamara, and I was also performance designer and video maker.
Our robots are called Filip and Danka. The main robot is powered by 14.8 volt battery. Voltage is then converted by 6 step-down converters. For moving, we use 4 DC motors controlled by 2 motor drivers. Moving is easier thanks to 4 mechanism wheels, which help us in coordinating our robot in every direction. As our main control board, we use Arduino Mega. For scanning the surroundings, we use 3 ultrasonic sensors and 1 pixie camera. The communication between components of our performance is done by an ESP32. For moving hands, there are 2 servo motors. Raspberry Pi 4 is connected by serial bus to Arduino Mega and is responsible for playing videos of leaves on the old recycled phone and for playing audios on the speaker. An amplifier is added to increase the volume of the speaker.
At the top, there's a mechanism for the eyes, which is controlled by 6 servo motors. In the right palm, there are 2 DC motors controlled by a motor driver and an infrared sensor for gripping the banana. The robot is switched on by a switch at the bottom of the robot, and the program is turned on by a hidden button. Another interesting feature is a phone holder, which we can tilt by a hinge for easier removing of the phone.
Minion Girl is made out of Lego and it's controlled by Lego Mindstorms EV3. We use 2 large motors for movement and 2 medium motors for moving hands. For orientation, she uses a gyro sensor for precise rotation and infrared sensor for measuring distance and to find the infrared beacon that's installed at the bottom of the main robot, an ESP32 for Bluetooth communication and a color sensor to indicate signals from the ESP32. Special functions are a rubber mechanism in the palm to grab the banana in communication with main robot. For this, we used a ESP32 and color sensor. These work on principle of optical gateway.
Our performance has some very well processed systems and mechanisms. These are the 4 best ones we think that help us the most in making the performance better. To scan stage, we used pixie camera in the main robot and ultrasonic sensors for precise measurements of the distance. Thanks to this, the robots can line up with other components of the performance. The only problem is that we must tune the pixie for different light conditions.
Our performance is almost automatic thanks to Bluetooth communication. We use an ESP32 board in Filip, Danka and the city background. This function starts the program in every component of the performance when needed. Also, thanks to sensors, robot can easily scan the progress of the performance and adapt to the conditions which happened very precisely.
The robot has a working eyes mechanism, functional hands with working palm, and an old phone with a speaker to imitate speaking. The mechanism of the eyes is working with 6 servo motors, 1 for looking up and down, other for looking side to side, and 4 for the eyelids. The videos played on the phone and the sound are controlled by Raspberry Pi 4, which is connected to the Arduino by a serial bus. These functions are meant to give the robot more realistic look.
Our props give unexpected and original elements to the story of the performance. These are our working props. The bin with the jumping cat and the shining city background. The bin is equipped with a jumping toy cat to scare the main robot. Ultrasonic sensor is added to indicate if the robot is in front of it. 1 servo motor is lifting the cat and the other is opening the bin. It's all controlled by Arduino Uno and powered with 4 AA batteries. There's also a step-down converter to convert the voltage and switch to switch the bin on.
For shining windows of the city background, we use an RGB LED strip. The LED strip is controlled by an ESP32 and is powered by 2 3.7 volt rechargeable batteries. The voltage is converted by a step-down converter and there's also a switch to turn the city on. The color cycle starts when ESP32 receives a signal from the robot. The sections of the city can be also disconnected for easier traveling.
We had a lot of problems during the process of making our performance, especially with software and communications. These are our biggest problems that we solved.